In this video we will be discussing about prime numbers, composite numbers and coprime numbers. So what is a prime number and what is a composite number? Well, a prime number is a number which has only two factors, and those two factors can be the number 1 and the number itself. And composite numbers are those numbers which are not prime. So the numbers which are not prime are composite numbers, and the numbers which have only two factors, the factors are 1 and itself, such numbers are prime numbers. So you must know how to calculate factors in order to determine if a number is prime or not. So for that I have a question: what are the factors of 15? I mean, how do you calculate the factors of 15? The factors of 15 are the numbers which can divide 15. So all those numbers which are less than 15 and can divide the number 15 are the factors of 15. So let us list all the numbers which are less than 15 here and find out which of these numbers can divide 15. So 1 can divide 15. So 1 is a factor of 15. 2 cannot divide 15. 3 can divide 15. 3 5s are 15. 4 cannot divide 15. 5 can divide 15. 6 cannot. 7 cannot. 8 cannot. 9 cannot. 10 cannot divide 15. Not even 11, 12, 13, not even 14. And 15 can divide itself. A number can divide itself. So 15. So the factors of 15 are the number 1, 3, 5 and 15. So the basic meaning of factors is that you can combine these numbers and multiply them in order to obtain the original number 15. So for example, I can combine 1 and 15 to obtain 15. I can combine 3 and 5 to obtain 15, and so on. So coming back to the definition of prime numbers, a prime number is the number which has only two factors, the number 1 and the number itself. So what are the prime numbers? So 2 could be a prime number because 2 has only two factors, 1 and 2. 3 is a prime number. 5 is a prime number. 6 is not a prime number because 6 has more than two factors. 6 has, let's say, 6 has 1, 2 and 3. And 6 has 4 factors, so 6 is not a prime number. 7 is a prime number. 13 is a prime number, and so on. You can calculate a lot of prime numbers. And the numbers which are not prime are composite numbers. So we could have 4, 6, 8, 10, 12 and so on as the composite numbers. Now the number 1 is neither prime number nor a composite number. So 1 is not a composite and not a prime. Okay, so let's move on to our next topic, which is primality testing. How do you determine whether a number is prime or not? So you have to follow these 4 steps in order to determine this. Let's do this with an example. I have the number p. So the number p is 147. The first step says that find a number n such that n square is greater than equals to p. So we have to find one such number whose square is greater than p. So let's find such number. Let's start from 10. 10 square is 100 and 100 is less than 147, so it's not going to work. 11 square is 121, so it's not also going to work. 12 square is 144. It's also not going to work because it's less than 147. And 13 square is equal to 169, which is greater than 147. So 13 is our n. So n equals to 13. Now the second step says that now find all prime numbers less than n. Find all prime numbers which are less than this number 13. So mind that 13 itself is a prime number. So the Prime numbers which are less than 13 are, let's start from 2, 3, 5, 7 and 11 and the number 13 itself. Now we have all those numbers which are less than n and which are prime numbers. Now the third step says that if p is divisible by these numbers, then it is not prime. So if our number p 147 if it is divisible by any of these numbers, then it's not going to be a prime number. Otherwise it's going to be a prime number. So let's see if 147 is divisible by 2. 147 is not divisible by 2 because 7, its units place, is not divisible by 2. 147, let's see if it is divisible by 3. So 147 divided by 3. 3 4s are 12. We have 2 as a reminder. 7 comes down. 3 9s are 27. So 147 is divisible by 3. So there is no need to go forward and check all these numbers, because we found out that this number is divisible by the numbers, by the prime numbers which are less than n. And from point number 3, it states that if p is divisible by any of these numbers, then it is not a prime number. So 147 is not a prime number. We have a question here. Is 123 a prime number? Yes or no? So let's do those steps again. Find a number n such that n square is greater than or equals to p. So we have p equals to 123. N could be anything from 10, 11, 12. So let's say 10 square equals to 100, which is less than 123. 11 square is 121, which is not also going to work. 12 square is 144, which is going to work because it's greater than 123. So all prime numbers less than 12 are, let's start from again, 2, 3, 5, 7, 11. So let's see if 123 is divisible by any of these numbers. So is it divisible by 2? It's not divisible by 2 because it's an odd number. Is it divisible by 3? So 123 divided by 3, 3 4s are 12, 3 comes down, 3 1s are 3. So again this number is divisible by 3. So is it a prime number? Let's check it. If p is divisible by any of those numbers, then it is not a prime number. So from our definition, from the steps, we found out that 123 is not a prime number. The answer of this question is no, it is not a prime number. The next topic is coprime numbers. So what are coprime numbers? Basically, coprime numbers are two numbers. It is a pair of numbers which have a common factor, and that common factor is the number 1. So let's take an example here. We have 8 and 11. So the factors of 8 are 1, 2, 3 is not going to be a factor, 1, 2, 4 and 8. And the factors of 11 are 1 and 11 because 11 is a prime number. And common factor, what are the factors common with these two numbers? Is 1. 1 is a common factor in these two numbers. So 8 and 11 are coprime numbers.